When we talk about training methods for large language models, one of the most significant innovations is reinforcement learning from human feedback. This method was developed to address a fundamental limitation of pretraining and fine-tuning. Pretraining teaches a model general language competence by exposing it to massive amounts of text. Fine-tuning adapts the model to specific tasks or domains. But neither guarantees that the model's outputs will align with human preferences, values, or expectations. A model may be fluent and knowledgeable, yet produce responses that are unhelpful, unsafe, or simply not what users want. Reinforcement learning from human feedback was introduced to bridge this gap, aligning models more closely with human judgment. The basic idea of RLHF is to use human feedback as a signal for reinforcement learning. Instead of training the model only to predict the next word or match labeled examples, we train it to maximize reward based on human evaluations. The process begins with a pre-trained language model. This model is capable of generating text, but its outputs are not yet aligned with human preferences. To guide it, we collect data where humans compare or rank model outputs. For example, given a prompt, the model generates several possible responses. Human annotators then rank these responses from best to worst. These rankings provide information about what humans consider good behavior. The next step is to train a reward model. The reward model is a neural network that learns to predict human preferences based on the ranked examples. It takes a prompt and a response as input and outputs a score representing how good that response is likely to be according to human judgment. Training the reward model involves supervised learning on the human ranked data. Once trained, the reward model can evaluate new responses without requiring human input each time. It becomes a proxy for human feedback, enabling reinforcement learning at scale. With the reward model in place, we fine-tune the original language model using reinforcement learning. The language model generates responses, the reward model scores them, and the reinforcement learning algorithm adjusts the language model's parameters to maximize reward. The most common algorithm used is proximal policy optimization, which is a stable and efficient method for training large models. Over time, the language model learns to produce outputs that score higher according to the reward model, which means they are more aligned with human preferences. This process transforms the behavior of the model. Before RLHF, the model might produce verbose, off-topic, or unsafe responses. After RLHF, the model becomes more concise, relevant, and aligned with user expectations. It learns to avoid harmful content, to follow instructions more faithfully, and to provide information in a helpful manner. RLHF is not perfect, but it significantly improves the usability and safety of large language models. One of the challenges of RLHF is collecting high-quality human feedback. Annotators must be trained to evaluate responses consistently and carefully. They must understand the goals of alignment, such as helpfulness, harmlessness, and honesty. If feedback is inconsistent or biased, the reward model will learn flawed preferences, which can distort the behavior of the language model. Scaling human feedback is also difficult, since annotating large datasets requires significant time and resources. Researchers are exploring ways to make feedback collection more efficient, such as active learning, where the model selects the most informative examples for annotation. Another challenge is balancing diversity and alignment. If the reward model is too strict, the language model may become overly cautious, producing bland or repetitive responses. If the reward model is too loose, the language model may drift toward unsafe or unhelpful outputs. Finding the right balance requires careful design of reward functions and ongoing evaluation. It also requires transparency about what preferences are being encoded. Human feedback reflects human values, but those values are not universal. Different cultures, communities, and individuals may have different expectations. RLHF must navigate these complexities to produce models that are broadly useful and fair. RLHF also raises questions about interpretability. The reward model predicts human preferences, but its internal workings are opaque. We can see which responses it scores highly, but we cannot easily explain why. This makes it difficult to audit or debug the system. Researchers are investigating ways to make reward models more interpretable, such as by analyzing attention patterns or probing representations. Greater interpretability would help ensure that RLHF is aligning models in the intended way. Despite these challenges, RLHF has become a standard method for training large language models. It is used by leading AI organizations to align models with human preferences. It has proven effective in improving safety, helpfulness, and user satisfaction. It represents a shift from purely statistical training to training that incorporates human judgment. This shift is crucial for building AI systems that interact with humans in meaningful and trustworthy ways. Let us look more deeply into the mechanics, implications, and future directions of reinforcement learning from human feedback. One of the most important aspects of RLHF is the design of the reward signal. The reward model provides scores based on human preferences, but the reinforcement learning algorithm must translate these scores into parameter updates. Proximal policy optimization is commonly used because it maintains stability by limiting how much the model's policy can change in each update. This prevents the model from making drastic shifts that could destabilize training. It ensures gradual improvement toward alignment. The reward signal itself can be shaped in different ways. In some cases, it is based purely on human rankings. In others, it incorporates additional objectives, such as penalizing unsafe content or encouraging factual accuracy. Multi-objective reward functions allow the model to balance competing goals. For example, a model may need to be both helpful and harmless. If it is too helpful without regard for safety, it may produce dangerous instructions. If it is too harmless without regard for helpfulness, it may refuse to answer legitimate questions. Balancing these objectives is a delicate task, requiring careful tuning of reward weights. RLHF also interacts with scaling laws. Larger models tend to benefit more from RLHF because they have greater capacity to adapt to complex reward signals. Smaller models can be fine-tuned with RLHF, but their improvements may be limited. This raises questions about accessibility. If only very large models can fully benefit from RLHF, then alignment may remain concentrated in organizations with the resources to train them. Researchers are exploring ways to make RLHF more efficient, such as by distilling aligned behavior from large models into smaller ones. This would democratize access to aligned models, making them available to a wider range of users. Another dimension of RLHF is generalization. The reward model is trained on specific examples, but the language model must generalize to new prompts and contexts. If the reward model is too narrow, the language model may overfit to the training examples and fail to align in broader situations. Ensuring generalization requires diverse feedback data and robust reward modeling. It also requires ongoing evaluation in real-world settings. Alignment is not a one-time process but a continuous challenge, as models encounter new tasks and users with evolving expectations. RLHF has implications for ethics and governance. By encoding human preferences into models, RLHF raises questions about whose preferences are represented and how they are chosen. If annotators come from a particular cultural or social background, their judgments may not reflect global diversity. This could lead to models that align with some values but not others. Addressing this requires diverse annotation teams, transparent documentation of alignment goals, and mechanisms for user customization. Some researchers propose personalized alignment, where models are fine-tuned with feedback from individual users. This would allow models to adapt to personal values and preferences, though it also raises privacy and safety concerns. RLHF also intersects with safety research. One of the goals of alignment is to prevent models from producing harmful outputs. RLHF can reduce risks by teaching models to avoid unsafe content. However, it is not foolproof. Models may still generate harmful instructions or biased language. Safety requires multiple layers of defense, including data filtering, rule-based constraints, and post-processing. RLHF is a powerful tool, but it must be combined with other methods to ensure robust safety. Looking to the future, RLHF may evolve into more sophisticated forms of human-AI interaction. Instead of static feedback collected during training, models could receive dynamic feedback during deployment. Users could provide ratings or corrections in real time, and models could adapt continuously. This would create a feedback loop where models learn directly from their interactions with users. It would make alignment more responsive and personalized. However, it also raises challenges of scalability, consistency, and security. Real-time feedback must be managed carefully to prevent manipulation or abuse. Another promising direction is combining RLHF with other alignment techniques. For example, constitutional AI uses predefined principles to guide model behavior, while RLHF uses human feedback. Combining them could provide both consistency and adaptability. Models could be trained to follow general principles while also learning from human preferences. This hybrid approach could strengthen alignment and reduce reliance on large amounts of human annotation. RLHF also opens the door to research on meta-alignment. Instead of aligning models to specific outputs, meta-alignment seeks to align models to the process of alignment itself. In other words, models could learn how to adapt to new feedback paradigms, new reward functions, or new ethical frameworks. This would make alignment more flexible and future-proof, allowing models to evolve alongside human values and societal changes. From a technical perspective, RLHF continues to push the boundaries of reinforcement learning. Training large language models with reinforcement learning is challenging because the action space is enormous and the outputs are complex. Traditional reinforcement learning was developed for environments with discrete actions and clear rewards, such as games. Applying it to language requires innovations in reward modeling, policy optimization, and stability. RLHF has driven progress in these areas, contributing not only to language modeling but to reinforcement learning research more broadly. In conclusion, reinforcement learning from human feedback is a transformative method in the training of large language models. It addresses the limitations of pretraining and fine-tuning by incorporating human judgment directly into the training process. It involves collecting human rankings, training a reward model, and fine-tuning the language model with reinforcement learning. It improves alignment, safety, and user satisfaction. It raises challenges of data quality, diversity, interpretability, and ethics. It interacts with scaling, generalization, and governance. And it continues to evolve toward more dynamic, personalized, and hybrid forms. RLHF is not the final answer to alignment, but it is a crucial step. It represents a shift from purely statistical training to training that incorporates human values. It is the reason modern large language models can be both powerful and aligned, capable of serving human needs while respecting human preferences. As research advances, RLHF will likely remain central to the development of trustworthy AI, shaping not only how models are trained but how they interact with society at large.
If you find this video exciting, please like, subscribe, and turn on notifications. See you in the next AI for Beginners educational video.